Coming into VIPER and coming into undergrad in general, I knew I wanted to do graduate school. I loved doing research from my experiences at Berkeley, and I really liked school. So I always knew I wanted to do graduate school. But given my experiences in the RAP group, I know I want to do research in computational chemistry and computational material science, specifically relating to energy, of course, because I'm in VIPER. I think one thing in the field is that there are computational chemists who develop models for how to calculate all of these things for different molecules and different materials, but they don't really think about the applications. And then there are computational material scientists or computational chemical engineers who just use the tools without modifying them and just report whatever the tools are telling them. So I want to operate between both spaces, developing new models so we can really understand these renewable energy technologies and optimize them. Right now, my main interests are in solar because the sun is a super abundant source of energy. And if we can really harness it, that can solve a lot of our energy conversion problems right now.
I would say I centered my academic training, also my technical career around the battery technology. I personally found it a very, probably one of the most feasible and efficient way to substitute fossil fuels by the applications of EVs and large-scale energy storage. That is why I'm particularly excited about that. There is this Formula race car team here at Penn called Penn Electric Racing, and I have been happily involved for the past 3 years. I have led mechanical design and manufacturing of the battery packs. So after graduation, I'll be interning as a cell materials engineer. After the internship, I'll come back and finish my master's in mechanical engineering. And I truly appreciate VIPER has given me the training in the past for that.
I guess in high school, I did a lot of research understanding photovoltaics in rural communities. My grandparents actually, in South India often experience power outages, and I was interested in understanding, okay, why aren't there more accessible forms of energy in these areas? So I think energy accessibility is a very important area, but I think beyond that, just the scope of energy research goes beyond simply just making better solar panels or better wind turbines or things like that. It's really improving the decision systems that are involved with all kinds of energy infrastructure. So better grid management, better transportation, and I'm involved with some of those activities on campus at Penn through extracurricular organizations like Penn Electric Racing and of course my VIPER research as well.
So I've worked in 2 energy-relevant labs, one of them being at the anesthesiology department of the Children's Hospital of Philadelphia under the mentorship of Dr. Wan, where I'm looking at EEG data, and specifically my energy-relevant project was trying to minimize the use of inhalational anesthetics that contribute in air pollution. And the other lab that I've worked on is at Mod Lab under the mentorship of Dr. Mark Yim, where I worked on basically creating a sustainable alternative to air conditioning units that will be powered using thermal energy stored in ice. And why it is important to me, of course, I'm very excited and passionate about the research I'm doing and learning while I'm doing it and hopefully contributing and having an impact. And I think it has been one of the most enjoyable experiences of my undergraduate years.
So since my freshman year, I've had the opportunity to work with Professor Igor Bargatin in the Department of Mechanical Engineering and Applied Mechanics. And our group's goal is to make these lightweight, thin film structures that can levitate in outer space. My main role is to use computer software to build these structures and simulate them. And every Friday, I meet with a group, including Professor Bargatin, and I receive feedback and trying to optimize my design even further. And as a senior, I'm actually pretty well experienced with this work.
Being from Houston, I think that having experienced Hurricane Harvey during high school, that kind of was a big part of why I chose to kind of be in sustainability in the first place. And my first real summer of research was in the Vagelos lab, really focusing on computational ways to improve the efficiency of hydrogen fuel cells, specifically like the catalysts that go in them to speed up the reactions in the fuel cells. And in my second summer, I really focused on a completely kind of new project with Dr. Gerald Mack in the Gerald Mack lab, and that was really focusing on whether or not kind of ice cracks could heal over themselves and whether or not kind of fracture patterns in ice could exhibit maybe the same properties that crack patterns in other materials that had been studied before, whether they were the same or different, things like that. So.
I'm majoring in mathematics and chemical engineering. So my first semester I did take a math class that I did enjoy, so I thought that I would want to stick with math. But chemical engineering was, I just met some students in the major that I thought were really interesting and told me about the field, about process engineering, all the different things that you could do with chemical engineering. So I've decided to roll with chemical engineering, and I think that was the right choice.
So I've been doing energy-related things for almost 8 years, from high school into college. So in high school, I worked with an organization called 1 Million Lights Philippines, where we provided solar lamps to off-grid communities. And here at Penn, I've been working with the Bargain Lab on microflyers using photophoretic levitation. So I think something that I've learned and something that I've experienced through my work in high school was the tangible impact that energy has on people's lives. You could see how giving these families this one solar-powered lamp really changed their lives. And then now in college, doing this more complicated projects, like I can see how the impact of like more advanced research can have on a larger scale, not just on like a smaller community, but on like a global scale. So I think for me, that's what really drives my interest in energy and why I want to keep doing research in this field.
I think what I enjoy the most about the VIPER community is definitely the people. And I think even though we're all going our separate ways after graduation, I'm sure we'll all look back fondly at the memories we made as undergrads in VIPER. I think VIPER provided me with a platform to dive deeper into a specific domain of energy research. In my case, is carbon capture. I think coming into VIPER, I wanted to contribute to mitigating global warming and climate change in a broad context, but I think being in VIPER provided me with a more direct path into contributing and, I guess, achieving more meaningful impact to achieve my goal better. But yeah.
I think what VIPER provided me is an opportunity to explore the different applied sciences and engineering courses and taken the two that interest me the most and try to make something out of it through the research opportunities here. Currently, I'm also doing sub-matriculation in nanotechnology. So after graduation, I'm planning to work something related to semiconductors or just nanotechnology stuff. Yeah.
Through VIPER, I was able to just grow my interdisciplinary mindset and learn how to learn, and just became super curious, and allowed for me at SpaceX to do literally everything from RF engineering to working on the second stage of the Starship rocket's electronics, to even doing mechanical engineering. And I never took a mechanical engineering class in my life, but that's how it helped me at SpaceX, because that interdisciplinary mindset just carries over, and I was able to get an understanding of the entire rocket business and almost all the engineering that goes on a fundamental level, enough to be able to solve any problem that's thrown at me or learn from experts around me.
So my research experience actually started in freshman year, and I have been working with Dr. Liang Feng for all 3 summers at Penn, and this has been a very valuable experience for me. VIPER helped me through every single aspect of this process, all the way to helping me present at the poster sessions in the Energy Week. All of these are valuable experience in my research experience, and this helps me to build expertise in the field of optics and photonics, and also as well as in the energy research.
What I really like about the VIPER community is that everyone is targeting energy from a different angle. So I really like that I can talk to pretty much anybody about their research and hear something completely different and learn something new every single time. And I think because everyone's exploring something different, it makes the conversations we have when we do ultimately get together so much better. While we are also all very similar in that we have like the same very clear goal with the clean energy transition, same passion for research, and we're able to kind of talk about that more whenever we're in person.
For me, the VIPER program has been like a good support system and people that I can always go back to. I have been a VIPER peer advisor since my sophomore year, and then this is my 3rd year doing it. And each year I have been bonding very well with my advisees, and especially, that's why I mentioned like last year, we did like weekly dinners, and I made a lasting relationship from that, and I'm pretty grateful for that.
Yeah, being part of the VIPER community, it means being surrounded by super driven, super motivated, right? I mean, everyone's interested in the same thing, everyone's passionate in the same thing, right? We care about the earth, we care about the sort of energy sources that we're using, and we want to make a difference. I think being in that community, being surrounded by all these people, you can't help but feel in awe at all times, and like, I should be doing something, and you know, you are doing something.